All right. So the first thing that I want to do is kind of review, well, what is that compound interest formula? All right. And I'm just kind of write it out, but I want us to kind of understand what each variable stands for along the way. So as we go through these problems, what I want to do is not just give you the formula anymore. I want us to kind of just pick apart what we need to from the situation and just plug those values in. All right. So I start with A equals, and what is A? What does that variable stand for in each of these situations? Right. So the final product or the final amount of money, whatever it may be. Good. Equals P. Well, what's P stand for? Yeah, the initial price or the principal, whatever I'm putting in, times 1 plus R divided by N. What's R? The interest rate. N, what does that stand for? Kind of talked about this when we were going over the homework. Right. So you're saying semi-annual, annual, quarterly, all the amount of times that something is compounded over a yearly basis, right? And then it's raised to the N times T. So that same number times T, which is the total amount of time that you're looking at this account or this loan or this stock, whatever the situation is. Okay. So that is our formula. Hopefully that is a good refresher for us heading into today's practice. All right. First example that we have, it says a Bensalem student is heading off to college. All right. Much like some of you in the next year or a couple of years. They're gearing up to pay for their first year of school and are comparing student loans. All right. Very normal thing, could possibly or more than likely pop up in your lives. All right. One loan is $7,500 principal, $7,500 with a 5.5% interest rate compounded annually for the 4 years that you would be in school. All right. The other loan is $6,500 with a 4% interest rate compounded semi-annually for the same amount of time. So the same 4 years. And what we're trying to figure out is which loan will grow the least for us to choose, right? Because if we look at a number in the end there, we want to choose the option that's going to be the least amount of money so we don't have as much debt. All right. And this is something, if I can take a pause and talk about this on a realistic side of things. When you're going to school, you might have to take out a personal loan and you want to make sure that you have all the information to kind of compare between different companies that are going to offer you a loan. There's something called the FAFSA, which is like the government, and they give you money to go to school. So you might have to take that, but then on the side, you might have to take personal loans depending on what school you go to. All right. So this is, a realistic connection to what you might have to do in the near future. So what we're going to do if we're comparing these loans is go through and do the math. So loan 1, we'll do on this side. We'll set up an equation. Loan 2, we'll do on this side and set up an equation. And then we'll see which one accumulates the least amount of debt for us. All right. In each of these, I'm solving for that final value. And if I look at loan 1, so the first one they talk about says one loan is $7,500 principal. So I'll plug that in for P. What's my interest rate for that same loan? Good, so 0.055. It's compounded annually. So how many times does that happen a year? Just once. Good. Raised to the 1 times 4, since we're taking a look at this over the course of those 4 years. All right. And what we'll do is we'll just do the math for one of these loans at a time. So we're not going to do too many things at once. 0.055 divided by 1 is just going to give me 0.055. If I add 1 to that, I have 1.055 raised to the 4th power, obviously from the 1 times the 4. All right. So I just did 2 steps at once there, dividing by 1 and then adding 1. Very similar to on Friday, you're going to need to use some kind of calculator or some resource to help you out to solve some of these. So I have 1.055, raising that to the fourth power. Gives me 1.238824651. Remember what we did back on Friday for each of these was kind of rounded to the nearest thousandth. So it gave us a little bit of a closer look, maybe a better estimate into what that final value actually is. So if I round this decimal to the nearest thousandth, what's going to be the number that I use? Thousandth is 3 decimal places. Is it bad?
No, I just don't wear my glasses.
1.23, not 4.
I mean, not
9, right? You know what's funny is I made the same mistake last class period. 1.239. All right. And then I'm just going to multiply those numbers together. So I'll do 7,500 times 1.239. And I get $9,292.50. Okay. Which is also something that could happen. Your loan over time will grow. So it's not like, oh, I took a $7,500 loan out. I have to pay back $7,500. The loan still grows continuously. It grows on interest. So you have to pay back more than you actually borrow. Right? So that's why student loans are a pain. Go to a cheaper school. Loan 2. If I set this up, again, solving for that final value, my principal is $6,500 this time. What's my interest rate for this particular situation? 0.04, good. This is compounded now semi-annually. So how many times does that happen over the year? 2. And I'm still looking at it for 4 years. So 2 times 4 is my exponent there. All right. 0.04 divided by 2. What's that going to give me? Oh, you do not need a calculator for this. 0.02. What's 4 divided by 2? 2. Just put a 0.0 in front of it. And then what's 1 plus 0.02? 1.02. Good.
It's a calculator for everything. Like 2 plus 2, I'll use a calculator.
That's so bad. 1.02 to the 8th power. And I got the 8 from the 2 times 4. It's going to give me 1.171659381, whatever. I'm going to round that to the nearest thousandth. And what's going to be my decimal that I'm going to use here? 1.172. Good. Let's see what our grand total is. So I'm going to take the 6,500, multiply it by 1.172. And I get $7,618.00. So if I'm looking at this, right? Loan 1 and loan 2, well, which loan would you want to take? Which is the best option for you? 2, right? Because that's creating the least amount of debt, which is beneficial. So in this one, we're going to take loan number 2. But still, you recognize that it's still going to grow, right? It's not that I took a $6,500 loan out, I have to pay back $6,500. No, you have to pay back almost, $1,100 more. Totally is. And that's a teacher that's telling you that. What are you gonna? You're also a sophomore. You have plenty of time to learn, learn and grow. You're also 16.
Well, they expect you to know so early. They're choose your classes.
You know who Jeff Bezos is? You know who Jeff Bezos is? He made Amazon. You know when he made Amazon? When he was like 30 years old. Yeah. So I don't think Jeff Bezos was like, oh, I'm 16. I don't know what I want to do. You can be, and now he's the richest man in the world. You do not have to put that much pressure on yourself to know what you want to do at 16 or 20 or 25 or 30, like Jeff Bezos. No shot. You know how different you're going to be in 2 years and 5 years?
I know.
For those of you that are at home, we're going on a rant about other stuff. So if you can't hear what's going on, you're probably very lost. But moral of the story, you just chill, relax, be a teenager, figure yourself out, and then you can figure out what you want to do. Because what you want to do is not who you are. You know that, right? Okay. Anyway, Emma's not going to college, and we're going to number 2. All right. You're setting up a retirement fund. You don't want to touch this account until you are 40 years, until 40 years from now. You want this account to grow to become $150,000 by the time you retire. How much should you put aside now if it is compounded semi-annually at 10% interest rate? All right, let's break down all this information. So the first thing that we want to kind of recognize as we're going through some of these problems is, what am I going to solve for? So it says, how much should you put aside now? So what variable do you think I'm solving for in my list there? If I'm trying to make $150,000, I know the amount of time, I know the rate, solving for P, right? I don't know how much I need to put into this, all right? So what should I put in for A? What's my variable gonna be? Or what's the value for that variable? 150,000, right? So you're saying, all right, I'm 20 at 60. I don't want to touch this account. So 40 years away, but I want to have $150,000 in there. Okay. Solving for P. What is the interest rate? 0.1. Divided by, it's compounded semi-annually. So what is the number of times there? 2. Raised to the 2 times, this is taking place over 40 years, so 2 times 40. Okay. Any questions about how I set that up? All right, let's see how good we are. 0.10 divided by 2 is what? 5, good. So 0.05. And what's 1 plus 0.05? 1.05 raised to the 80th power from the 2 times 40. All right. So in this example, I don't need to compare anything. I can just go through and solve this as is. So I'll do 1.05 raised to the 80th power, and I get 49.56144107. Well, if I'm rounding that to the nearest thousandth, what is the value there? I'm rounding this to the nearest thousandth, this number. Good. So 49.561. Okay. And then what do I have to do on both sides to get P by itself? Good. Divide by that 49.561. So comparative to some of the other questions where I just multiply my values together in the end to get my final result, when I'm solving for P, I have to divide on both sides. When I do that, somebody tell me what the final answer is. Good. 3,026.57. I think I might have forgotten something here. I did it by 49,000. Sorry. So 1.5. It should be the same thing. You're just gonna move the decimal points. Divided by 49.561. There we go. So $3,026.57 is your initial investment. Now, whether this is as realistic as possible to find that exact account with that interest rate compounded that many times, it might be a smaller interest rate. However, if this was realistic, think about having to put away just $3,026 and 40 years from now, and all of a sudden you have $150,000 for not doing anything. Pretty sweet deal, right? We kind of talked about that a little bit on Friday. Choosing what's best for you, choosing the right account so that your money grows as much as possible. Okay. Any questions about number 2? So when you go to open up savings accounts and retirement funds, things like that, those are the questions you need to ask. What's the interest rate? How many times is it compounded? How can I gain the most money that's possible? All right. Number 3, after your summer job, after your summer job, you think it's best. I don't know why it says that. You think it is best to reinvest it into a stock. So the money that you gained, you want to reinvest into a stock. You're going to take $4,000 and put it into an ETF. An ETF is kind of like a trust fund or a mutual fund. So what those things are is they take, for example, these are real trust fund or mutual funds that we're going to talk about. They exist in the real world. One of them, Vanguard Top 100. One of them is Invesco Trust. It's QQQ. So if you were to look at like stocks on your phone, because I'm sure you all have that app that you never look at, and you were to type in those codes there, that would pop up. So these are legitimate stocks. And they're called ETFs. They take like multiple companies and they invest your money into like, say, top 100 companies in the world. All right. And some of them are looked at often. So they kind of like interchange who's the top 100 every day, or maybe every week, or maybe every month. Some of them, they kind of just take those 100 and they leave it go for quite a while. Maybe they change it every 6 months. So semi-annual. All right. And these are very safe and secure options. So this is kind of, I know that stocks aren't for everybody, but this is an interesting fact. They don't grow as rapid as maybe one individual stock, but it's not as risky. So it grows over time. It just grows at a small rate. All right. So that's what you're going to take your summer money in this situation and put it into. Okay. Now for each of these two options, we're investing $4,000. All right. For Vanguard, so VOO, the interest rate is 7% and will be compounded monthly. For the Invesco Trust of QQQ, the interest rate is 7.5% and will be compounded quarterly. And we want to ask ourselves, well, after 5 years, how much more money am I going to have? So which is the best option for me? All right. Again, pretty realistic situation related to, putting your money into something, whether it's a savings account or in this case, a stock, and choosing the best option for yourself. So what we're going to do is the same thing as we did before. We have our two options here. And if we're looking for the future value, what variable are we solving for? A, right? That final total amount, solving for A. So for this Vanguard one in particular, I'm putting in $4,000. What was the rate for Vanguard? So that was the other one. 7. So what's that as decimal? 0.07. Good. It's being compounded monthly. So how many times that happen over a year? 12. And I'm raising this, I'm looking over the course of 5 years, so it's 12 times 5, or we'll simplify that to 60. Okay. So let's do the work for this. I have 0.07 divided by 12. 0.00583333 repeating. I'm going to round that to the nearest thousand, so it's going to be 0.006. Okay. And then if I add 1 to that, I'll have 1.006 raised to the 60th power from the 12 times 5. So again, I just did 2 steps at once, divided the rate by the number of compounds, and then added the 1. So now I'm going to take that number, raise it to the 60th power, and I get 1.431788412. Well, if I were to take that and round to the nearest thousandth, what's the number going to be? 1.432. Good. Everybody with me so far? Any questions? So now multiply those 2 numbers together. And after 5 years, grew steadily. I got $5,728.00. All right. Any questions so far? So I'm taking the same amount of money, that same $4,000, and now I am investing that into this other fund. What's the interest rate for QQQ? 0.075. That's being compounded quarterly. So how many times does that happen over the course of a year? 4. I'm raising that to 4 times 5 because I'm looking at this again over the course of 5 years. So when I plug this in, 0.075 divided by 4, get 0.01875. So we'll call that 0.019. And then we'll add 1 to that. So I have 1.019. Raised to the 20th power from the 4 times 5. When I plug that in, so 1.019 to the 20th power, I get 1.45708.095. If I round that to the nearest thousandth, what's going to be that value? 1.457. Multiply those together, I get 5,828. So what is the best option for us? QQQ, right? So it's better to have $100 more rather than 0, right? So notice that the only difference there was 100, but we'll still take that. So QQQ is our best option. All right. Now, again, whether that's 100% realistic or not, we're still getting an idea of comparison between 2 different things. Stocks are a little bit trickier because there's other things that you need to take into account. For example, like these company or these funds will take a percentage, very small percentage, but will take a percentage of your money that you gain for themselves as well. Looking at how often they give you what's called dividends. So they'll pay you back maybe quarterly for the amount of money that you put in. And what you're supposed to do theoretically Or what some of the more wealthier people in the world do is they take their dividends and then they just immediately reinvest. So they put that money back and they buy more stock. Makes sense. All right. Any questions about that example? All right. Last one. Number 4, very similar to what we've done so far. Get a summer job at Chipotle on Street Road. Nice. You want to take all of your earnings from the summer and put it into a savings account and watch it grow over the next 3 years. All right. So you work all summer. Maybe you're heading to college or you're, still in school, whatever you're doing, and you want to just make sure that that money grows over time. You end up making $3,500 for the entire summer, and you want to choose a savings account that's going to help you grow the most. All right. So very similar to the last example, what variable are we solving for? A, right? And maybe we'll call this just account 1 and account 2. And again, we're solving for A in both of these, so I'm plugging in the $3,500. It says one saving account compounds quarterly at an interest rate of 5.5%. So that's going to be 0.055. If it's quarterly, how many times does it happen a year? 4. And I'm looking at this over the course of 3 years in both situations. So I'll have 4 times 3 to set up that first account. Okay. When I go through and solve, I have 0.055 divided by 4, and I add 1 to that. So I have 1.01375 or 1.014. Raised to the 12th power from the 4 times 3. And that gives me 1.181559129. So what's that rounded to the nearest thousand? Right, so 1.182. And then when I multiply those two things together, so I have 3,500 times 1.182. This now becomes $4,137. That's not too bad, right? $600 or $700 just for sitting in an account for 3 years. Pretty decent gig. But that's just account number 1. Let's see if account number 2 gives us more money. So account number 2, I have $3,500 times 1 plus. What's my interest rate for account number 2? 0.045. This one's being compounded monthly. So that's how many times a year? 12. I'm raising this to 12 times 3. From, again, if it's compounded monthly times the 3 years that we're looking at this account. All right. .045 divided by 12 plus the 1 gives me 1.00375 or 1.004. So $3,500 times 1.004. 12 times 3 gives me the 36. So I raise 1.004 to the 36th power. I get 1.154552434. If I'm rounding that to the nearest thousand, what's going to be my value there? 1.155. And when I plug that in, I get $4,042.50. So when I'm comparing each of these options, which is the best for us? Which account should I go with? Account number one, right? It's about nearly $100 difference between each of those. So again, I'm going to take that value more than the other one. So I'm going with account number one. Okay. Any questions about that example or anything that we covered today? Hopefully you walked away not only understanding this process, but maybe something a little bit more on the outside of that as well, whether it was related to stocks or savings accounts or anything like that. All right. Any questions for me about any of these questions, this process, anything that we covered today? Okay.